Here's a lesson on estimating a population proportion. That's chapter 10.3 in your book. And in this video, I'll show you how to calculate a confidence interval for proportion-style questions. Some example of proportion-style questions would be, let's say we wanted to estimate the true proportion of students who drive to school, or the true proportion of students that have a job, and things of that nature. So they're proportion-style questions. We, of course, have our normal distribution that would be centered at P, and we're going to be dealing with some P hats. Okay, so first thing is the confidence interval, and we kind of worked over this in class, and there's two parts to it. There's the level C, and that's your percent confidence. In class, we talked about a 95% confidence interval, and that's the percent of the intervals constructed in the same manner that will capture the true parameter. So all day long, 95% of the confidence intervals to predict the true proportion of M&Ms will capture that true proportion of 24%. And the interval, which we calculated, is basically the estimate plus or minus the margin of error. Okay. Now on your formula sheet, again, I talked about this a little bit, but we have some formulas that were on the back side of the formula sheet, and we have a quick general formula for confidence interval, and it's the statistic plus or minus the critical value times the standard deviation of the statistic. And we'll be dealing with sample proportions, and we're looking at this formula right here, which should look familiar. Now, since we will never know the true value of P, that's the whole point of doing this, is to estimate. We use P hat to estimate the value of the parameter, and we will replace the standard deviation with what we call the standard error. Standard error. And that's really the standard deviation of the statistic. And in this case, we're going to use P hat 1 minus P hat over N, because again, we don't know P. We only have P hat, so that's really our only option to use in the formula. Okay, so another formula. So if I want to make a confidence interval for a population proportion, I take a simple random sample of N from a large population, and the formula is this: P hat plus or minus Z star times the square root of P hat 1 minus P hat over N. And again, we're just plugging and chugging. This P hat is the estimate, or the statistic. It comes from the sample. Z star is the critical value, and I did do a separate quick 5-minute video on how to calculate that. And this, of course, is just your standard error, or standard deviation of the statistic. Now, this whole right side, the plus or minus part, the Z star times the square root of P hat 1 minus P hat over N, that whole part is called the margin of error. So if you heard me talk about that in class, this is what I'm referring to. It's simply what you add or subtract to your statistic. Okay. Of course, this can only be done if the following conditions are met. So we do have 3 conditions. They are my least favorite part of the problem, but you do need to check them every single time. So the first is that an SRS. Okay, so the sample must be randomly selected, or the data must come from a simple random sample. Okay, normality, and this will look familiar, N P hat greater than or equal to 10, and N 1 minus P hat greater than or equal to 10. And again, that's just something you got to memorize. It's not my favorite part. It's not the most fun part, but you must check them every time. And the last one, independence, you're going to check to see that the population is greater than or equal to 10n. And a little trick for you, the greater than or equal sign always points to 10. So if you're struggling with that, just always point it at the 10 and you'll be good to go. Okay, now one last formula that we want to write down, and that's if you're asked to get the sample size. So sometimes I'll want to know how many people I should ask in order to get a desired margin of error. In class today, some of the confidence intervals for predicting M&Ms were really wide. And let's say we want to narrow that down. We talked about you need to increase the sample size. Well, I don't want to have to ask a 1,000 people if I can get away with only asking 500. That's, can be expensive. So I'm going to have to figure out, to get a desired margin of error, my sample size. And you'll use this equation, and you'll basically solve it backwards for n. And you'll always round it up. Okay, so here is an example. We just had the Super Bowl, so I will use a Super Bowl question. We wish to estimate the percentage of adults, 21 plus, who watch the Super Bowl at a house party. We survey 80 people and find that 68 watched the Super Bowl at a house party. Construct and interpret a 90% confidence interval for the true proportion of people who watch the Super Bowl at a home. Doesn't have to be your home, it's just somebody else's houses. You're not going out to a restaurant or something like that to watch it. Okay, so the first thing that we're going to go through is identifying the population and the parameter. The population in this case is all U.S. adults. Okay, 21 plus. And the parameter of interest in this case is, what are we trying to predict or estimate? And that is the true proportion of adults who watch the game at a home. Okay. Now, that's kind of generally what we're looking for, and now we're going to get into the conditions. Okay. Well, same thing we did today in the with the M&Ms is we need to get a p-hat. So in this case, 68 out of 80 watched the game at a house. So from our sample, our p-hat, our sample statistic is going to be 0.85. Okay. Now, we need to check our conditions. Okay, so we have three quick conditions. The first one, SRS, and often we'll have to assume. So we're going to assume the survey was randomly selected, the people in the survey. Obviously, I didn't go to somebody's house and ask them this question, because that might be an overestimation. So it needs to be random so that the sample is not biased, and then it's a good estimate of the true proportion. We need to check normal. Okay, pretty easy calculation. N p hat greater than or equal to 10, and n 1 minus p hat greater than or equal to 10. Again, normally I would use p in this case, but because I don't have p, I have no choice. So out of 80 people, 85%, that equals 68, which is definitely over 10. And if I take 80 times 0.15, that's 1 minus p hat, I get 12, and that's over 10. So that condition is met. And the third and final condition is independence. And we are checking to see if the population is greater than or equal to 10n. So if I plug in 10 times 80, I get 800. And I'm going to have to go ahead and assume that there are more adults in the United States than 800. So that's definitely met. All right, now, again, the conditions, you got to check them. It's annoying, but you really can't do any of the calculations unless these conditions are met. So now we do the fun part. And by fun part, I mean calculations. Okay, so first thing we're going to do is we're going to identify what type of calculations we are doing. We are doing a one sample, or we are calculating a one sample Z proportion. Or, I'm sorry, a one sample Z interval. 4 proportions. Okay, that's the name of it. The formula is p hat plus or minus z star times p hat 1 minus p hat over n square rooted. Okay, and that's a point right there, just identifying what formula I'm using. So now I'm going to plug in. My p hat was 0.85, and again, that came from up above. All right here. Plus or minus. Now, the z star comes from the 90% confidence interval. Okay? So because it's a 90% confidence interval, z star for 90% is 1.64. All right? And again, I'll go off to the side and show you that. Okay? If the middle's 90%, that means the tails are 10%. Divide by 2, that means the tails, one tail is 5% or 0.05. If I inverse normal that number, I will get 1.64. So that's where that comes from. Now, so I'm going to plug it in here. 1.64 times the square root of p hat 0.85 times 0.15, all that divided by n, which was my total in my sample, which we said was 80. All right, so out of 80 people, I get 0.85. And from this point, I'm just plugging and chugging right in my calculator. That gives me a standard deviation of 0.0399. 0.85 plus or minus. I multiply those two things together, I get 0.0654. Now, on a side note, that's called the margin of error. That's what I add or subtract to my statistic or my estimate in order to get my confidence interval. So that's called the margin of error. I subtract this from 0.85. I get 0.7846. I add it to 0.85. I get 0.9154. And that's my confidence interval. Now that's the calculation. And finally, I have to conclude. So I will make a conclusion. All right. And that's basically my interpretation. Okay. And this is the sentence. We are 90% confident that the true proportion of U.S. adults who watch the game at a home is between 0.7846 and 0.9154. Now, it's acceptable for you to turn those to percents, so you could call this 78.46% and 91.54%.